Good morning everyone. I am D. Sengoten, Assistant Professor of Physics, SNS College of Technology, Coimbatore. Today our topic is crystal physics. The overview about crystals, single crystalline, polycrystalline, amorphous materials, unit cell, crystal system, Pravec lattice, Miller indices, and finally crystal structures. So classification of solids. So basically crystal materials defined as two types, crystalline material and non-crystalline materials. So in crystalline materials, atoms or molecules arranged in a regular and periodic manner. Non-crystalline materials are amorphous materials. The atoms or molecules arranged in a random manner. So in crystalline materials, there are two types of crystals. The first one is single crystalline materials. Then second one is polycrystalline. In polycrystalline, crystals divided into number of layers. Then their diagram shows that amorphous solid, amorphous materials. So fundamental terms of crystals, the first one is lattice. The lattice, it is a point denoted as a position of atoms or molecules. Then the space lattice, the lattice lines, lattice points in a space is called space lattice. Then lattice point denoted as position of atoms. Then generally crystal equal to lattice plus basis. So we already know that lattice is equal to position of atoms or molecules. Then base is equal to unit assembly of atoms or molecules. So finally lattice point plus base is equal to crystal. So next topic is unit cell. So unit cell denoted as interaxial length and interaxial angle. For example, in a unit cell, in x-axis equal to a, y-axis equal to b, z-axis equal to c. Then angle of x-axis is equal to alpha. The next beta, gamma. So based on this interaxial length and angle, systems divided into several types. So there are seven crystal systems are available. So first one is cubic, second tetragonal, third orthorhombic, rhombohedral, hexagonal, monoclinic, then finally triclinic. So in cubic system, interaxial length of cubic A equal to B equal to C, then alpha equal to beta equal to gamma equal to 90 degree. In tetragonal, axial length of x-axis and y-axis A equal to B but not equal to C, then alpha equal to beta equal to gamma equal to 90 degree. Then orthorhombic, interaxial length of A, B, C all are not equal. Then interaxial angle alpha equal to beta equal to gamma equal to 90 degree. Then rhombohedral, A equal to B not equal to C. Then alpha, beta, gamma all are equal but not equal to 90 degree. In hexagonal, axial length A equal to B but not equal to C. Then alpha, beta equal to 90 degree. Then gamma equal to 120 degree. So in monoclinic, interaxial length of A, B, C all are not equal. Then interaxial angle alpha, gamma equal to 90 degree but beta not equal to 90 degree. Then finally in triclinic, all are not equal. Interaxial length and interaxial angle of triclinic, A not equal to B not equal to C. Then also alpha not equal to beta not equal to gamma not equal to 90 degree. So finally there are seven crystal systems are available. So the table shows that system value equal to 7, then axial length, interaxial angle of 7 crystal system. The number of possible types in a system. For example, in cubic, there are 3 types: simple cubic, partition cubic, and face cubic. In tetragonal, there are 2 types of tetragonal system: simple cubic, simple tetragonal, and partition tetragonal. Then orthorhombic, there are 4 types. Monoclinic, there are 2 types. Then finally, triclinic, trigonal, then hexagonal, there is 1 type: simple triclinic, then simple trigonal, and simple hexagonal. Then the next diagram shows that there's different types of crystal system. So in cubic system there are 3 types: simple, body centered, and base centered. Then tetragonal, 2 types: simple and body centered. Then next orthorhombic, finally 4 types of system: simple, body centered, base, and face centered orthorhombic. In monoclinic, simple monoclinic, then base centered monoclinic. Then last 3 system: hexagonal, triclinic, and rhombohedral. There are only one possible types is available, that is simple rhombohedral, simple hexagonal, then simple triclinic. So finally the diagram shows that the crystal position and atoms are molecules. So next topic is important lattice parameters in the crystal. So in crystal, the basic terms are lattice, lattice point, lattice line, unit cell, then available system, the number of possible types, the finally important lattice parameters in a unit cell or in a crystal. So first line shows that number of atoms per unit cell, so total number of atoms per unit cell. Second one, coordination number. So coordination number is known as nearest lattice points. Then atomic radius, half of the distance between any two nearest atoms. Then finally packing density of crystal or atomic packing factor. Okay, thank you.